Hello and welcome. Um, Today I'm going to talk about how to go about troubleshooting boombox motors for cassette mechanisms. Sometimes you will occasionally run into units that are bad or have problems like loud squeaks or something. This is in a really dilapidated, I think this is Sanyo M9980. This one's in pretty bad shape. In fact, it's missing a switch or so, and there's another part broken off, and somebody had drilled a hole into the cabinet and so forth. Anyway, the first thing I normally do is I make sure that the motor is getting voltage. Sometimes you can get, sometimes the way their motors are mounted, you can go ahead and measure the voltage pretty close there, but in this case, the wires to the motor here go through the other side of the main printed circuit board, and I got it measured off of there. And this thing here, I don't know if this can be seen here, it's actually got two wires. Looks like it's two wires coming into this. Sometimes I've seen it where they've had like three wires, but then that's would be used as a ground. And in case you're wondering like what kind of voltage, if you don't have the schematic or service manual, what kind of voltage would be coming into these boombox motors, well, then you'd have to go ahead and take a look into the battery compartment. So for example, if you knew that this took 6 D-sized batteries and they're each 1.5 volts, and you know, okay, it would be 9 volts. That would be basically how that works. So let me go ahead and turn this over to the other side so I can go ahead and show the measurement. Now this unit here, if you look down here, you can figure, okay, looks like it takes like, there's 3 batteries, one after another, and that's in 2 rows, so that would be 6 batteries times 1.5 volts, that's 9 volts. So say if I didn't have the line cord plugged in now, and I was running off an external power supply or something, sometimes it says on the side too, it might say side of the unit, the voltage. If not, you could always guess what you're supposed to read. So now this unit's pretty, you can see here, this is a pretty convoluted unit to work on. So it should be around 9 volts then. Let me go ahead and set this up so the 9 volts can be seen. So it's right there, it's 9.22, which is 100% correct. It's showing minus. I just have the leads backwards. This is a DC motor. So now in the event now that the motor, if the motor wouldn't run now with that 9 volt voltage, then we know we have a problem with the motor in itself, right? And then what we could do is, for example, we could unsolder these motor terminals here. There's 2 of them. Of course, you want to make sure you take a picture or mark where they go. I've noticed that like a lot of times some of these motors, like, they're not all reversible. You can only like hook them up one way. So that being said, let me go ahead and unsolder these the 2 motor terminals here. Again, there's only like 2, mostly there's only like 2 wires. If you do see a third one, which I've seen just in these particular boombox, maybe there's other ones, I don't know, but on the dozens of boomboxes that I've worked on so far, in general, it's just 2. So let me go ahead and unsolder that and show them what I do next. Now, again here, if we've got full voltage here and the motor wires are still connected, we can safely assume that the motor supply voltage, the voltage going up to the motor supply, is good. And if we got 0 voltage here, or it's really low or something, if it's really low, we could have a problem in the motor, or it could be a problem with the with the supply voltage shoot, that we don't know, so we'd have to go ahead and disconnect this and then go ahead and troubleshoot then. Either the problem would be like before then the motor, or it would be in the motor, could be in the motor itself. Now there's a switch in these cassette mechanisms. So if you had 0, sometimes that goes bad. Let me turn the unit over and show that. Now here you can see that switch I was talking about. You have to disregard the racket now. I've got the unit into play, and sometimes here this switch might be broken, might not be making correct contact, and then nothing will actually run. So let me go ahead and use my finger here. Look at that. Now the motor actually shuts off. Of course, when I hit the stop now, then it's off completely. Now here's the 2 wires coming directly from the motor, and I've got the ohm meter now hooked up, and you can see what I'm reading here, which is 16.8 or about 17 ohms. That's for these motors, you're always going to have a really low reading. If you read it like a lot higher, or it's open, then you know you have a different problem. I've even seen a case before where the one of the brushes inside was loose, and that motor was reading basically open. Now you see I'm turning the motor right now by hand. You see it there, it'll always go back to that low reading. I would say that's about a low ohm reading like this is under 20 or 20 some ohms here. That's about normal. And when you turn this thing, I mean, you shouldn't feel a lot of resistance here. If you feel a lot of resistance here, then you've got a problem somewhere, and you're gonna have to take this thing. You're gonna have to take this thing apart, or either that, or swap it out for a different used motor if you can. See how easily I'm turning this? Sometimes too, if you apply voltage, and let's say I applied it before to an external power supply, and then I started turning it, and then it ran. It just needed that extra boost. Of course, that tells you right there there's something wrong inside too. So again, if you are not getting voltage up to the motor, and you've got the motor disconnected actually, and you're measuring from the wires, you got to be sure to check this motor switch here, the leaf. This is a leaf switch. A lot of times you might have a problem with that, and then basically you just got to work your way back. Sometimes you've got like motor control circuits. You just got to see what they're putting out. I mean, theoretically you could have a motor that's running too fast too, but I've never run across that. And then I would go ahead and check if it's got any electronic control circuits there. I would go ahead and make some measurements there.